Mm-hmm. 6 division. Mm-hmm. There is. Let's grab it and go. The only interesting thing about 6, I agree with you. The only interesting thing about dividing functions is that there's an extra little step that pops up. Right? But I don't like to think of that extra step as only in these specific types of problems. That extra step is in any problem ever. If you ever are just working a random problem and you come across this thing, it's really important to go off in your brain to the side, make a little side note. Hey, I just encountered this. It's really important. So let's see it happen. Okay, we've got ourselves, you said probably D to start. So I'm going to go ahead and do red, blue. So we got x squared plus 3x minus 3 divided by blue. Okay. Does it factor? It doesn't look like it factors, huh? I don't think it does.
Because you can only
really
factor the top.
I don't think you can even factor the top, really. I mean, you could factor 2 out of the bottom, but then you'd have 2 factor x minus 3 over 2. That's not even any prettier. Oh, but it kind of is for one reason. So I guess that's your answer then.
Really?
Yeah, because you can't factor it, you can't do anything. But there's one side note you have to make. Star, star, star. Domain restriction just started. Because we divided, there's a domain restriction, right? And the domain restriction would be x better not be 2 over 3. Because the bottom...
Would it be 3 over 2?
Whoops. I was just trusting you. Because the bottom, if you want to get the steps, the bottom better not equal 0. That would be bad, right? So then we could just go off to the side and go 2x minus 3 better not be 0, which means 2x better not be positive 3, which means x better not be 3 over 2. But that's not technically how we write domain. How can we convert that into an actual domain? Mm-hmm. Include or not include? Good call. Unite it with?
3 over 2.
To infinity? That's a pretty way to write the same thing.
And beyond.
And then to infinity and beyond. Well, that's a final answer, but sometimes this same type of problem will say determine the composition and find the domain, and that's what we just did. But the reason I think it's worth pointing out in a problem like this is because if it's a different problem and it's asking for an actual answer like f of 3, right, or f of 2, or f of a plus 1, whatever, and you get to the end of your problem, and just for some random happenstance, your answer was 3 over 2. And you didn't do this little sidestep of a domain restriction, it wouldn't be right. Yeah? Like this is just telling you, hey, there's one number we can't consider. All the other numbers, fair game to be answers. There's one number we can't consider. So technically this 6D doesn't ask for that. Technically. Usually it does. I just typed it short or whatever. But it's as soon as you see anything on the bottom, it's so important for our brains to go domain restriction. Likewise, as soon as you see anything inside of a square root, I would do the same thing. Just because it's good practice. As soon as you see those two domain restrictions to consider it. Not to report it, not to make it your answer. Your answer isn't that green thing, actually. Your answer is this box. But it's a good consideration. Okay. What else?
Well, it's just a quick question.
Yeah, please.
For the same one for this one.
Okay.
It's just looking at like E and C. So would it be better to add and subtract before applying the number or after?
For E and C, would it be better to add or subtract? Well, for C, there's no number, so you
can just add.
You have to add and combine like terms.
But
For E, I think I always just plugged and chugged first. So for E, I think I always just did f of 3 minus, this would be E right here that we're doing, minus g of 3 equals, and then you got to go actually find those things. So f of 3 looks like it's 9 plus 6 minus 3. Am I wrong? 9 plus 9 minus 3. Minus, and then g of 3 is 6. It's just 3.
Yeah.
So
because it's 6 minus 3 is 3.
Kind of like that. Maybe do it a little prettier.
Actually,
What?
yeah. Oh yeah, because if you did it after, because like
You could do it after. You could totally do it after, and you'd be perfectly in the right.
no, because I think we'd get a different number. Because you get x squared plus 5x minus 3.
No, it's minus.
Oh, right.
Minus 2x plus 3.
So it'd be x squared plus x.
And then if you plug in 3, you would get 9 plus 3.
Okay.
So, either way.
Can you do the inverse or?
Yeah.
That's
What problem is that?
the inverse is 7. Can you do 17, please?
Sure thing. Oh, yeah. This is fun.
Oh, no, it wasn't.
I was helping a student with this, not inverses, but at church the other day, somebody was working on calculus, and this property was the property that,
Stop them.
how do I paste?
Right? Did you right click?
Yeah. It used to work.
Oh my goodness.
Double click. Go down here. Paste. No. Dot. Well, that means I have to reattach my keyboard and everything. It's a lot of work. Usually, what a sad day.
Let's play a violin now.
I have a really small violin for me. What on earth am I supposed to do about this situation?
Why does it always happen?
I don't know. Computers are hard, man. Control V. Did it work? Copy. All right. Well, sorry about that, guys. Sorry for the delay.
This is so weird.
I don't know. Watch. This will work, though. Boom. See how fast that was?
This is like, I don't think this even happened last
I do this all the time. This is like...
Yeah.
All right, which one are you asking for, Annie?
D.
Okay. Oh, yeah. So I was helping a student with something, and he got into this long equation with these, like, y prime of x plus xy plus y double prime plus, I don't know if it was like 5x squared or whatever. But it was just a long thing. But his only goal was to get the y primes. I think there's one over here as well. The y primes out, right?
Right.
And sometimes it's really hard to see how do I turn 2 of something into 1 of something. And that's the mission of this type of problem. And so I actually showed him this problem. Except I made it simple. I was just like, hey, this is the most common problem where this happens on. This property that we're going to see that is a little not obvious at first. So, but inverse properties, you know how to do. So what's the first thing you do when you see an inverse?
Change X to Y.
Well, I would even take one extra step, and I would do y equals first. Just so you have prettier things to work with. And then I would swap x and y. Right? So this is for inverse, if you weren't paying attention to which one we're doing. This is for inverses. Cool? Sorry, I'm just going to hide this. Boop. There we go. So we're switching them now, right? So we got x equals 2y plus 1. And that's where the problem is, because we have 2 y's, but we want 1 y. So it's not always obvious how to get those y's out of there.
Can we multiply both sides?
Multiply by y minus 1. And what you do to one side, you got to do the other side? Okay. Y minus 1 times x equals 2y plus 1. Well, now we have y's on different sides.
Wait. Where's the X come out from?
Remember,
We still have
because
that
we-
X on the left side.
Oh, okay.
We switched
Okay.
y with the 2 x's.
I saw it now.
That's a good picture right there.
Okay.
Okay, what else? I know you might have, we did this problem a lot last year, so it might be like a,
So it just leave it like that.
well, we got to get y by itself.
Oh, okay.
So you can distribute the x.
Mm-hmm. This is a little tricky thing where you like, a lot of people, we're going to keep going, but a lot of temptation is to like start doing like divide by 2y or something to try to cancel y.
That's what I did.
Yeah.
Why it's not?
So it's a little tricky, but Devin's on the right track right here. He said we're going to distribute the x first, kind of get everything on the same playing field, no parentheses, everything looks the same. So we can combine like terms is the real point of that. xy minus x equals 2y plus 1. And now the y's need to be alone, right? And how do we get the y's by themselves? Send them to the same side. So xy minus 2y. And you know what? We don't want that x over here. Equals 1 plus x. And now I see a shortcut to turn 2 y's into 1 y. Factor it out. We turn 2 y's into 1 y legally in the math world by factoring 1 out. So we're left with y, big old parentheses, x minus 2 equals 1 plus x. Did I mess up?
No, I was just like, just organization for me. It's like, it's left by x plus 1. So then you divide by x.
Then we can divide that parenthesis term to cancel it. And we are left with y equals,
X plus a 1 plus.
yeah, we can do x plus 1. Which is not actually y, it's actually f invert. Ooh,
Okay.
I'll zoom out. Yeah.
When it comes to domain, does the domain have to be? We keep the domain from the last one and then add that domain too? Or?
Did it ask for domain? It didn't. So that's what your answer. I would do 2 different things with domain if I were solving this problem. Not that I have to write them, but my brain just should at least think them. My brain should think, hey, I'm looking at this problem, and I can think of one really specific thing right now that I can say real quick. X better not be 2. I'm not even going to write the full domain because it didn't ask for it. I just know I could. I could go write that domain with that information.
So whenever it's come out to the answer, we have to write X inverse. I mean F inverse.
Yeah.
Or X. Okay.
Because it's not Y, technically.
Okay. So I literally just put the number in there.
Mm-hmm.
The answer. Thank you.
Right. That would be the second thought I would have. Would be, hey, wait, we actually learned that inverses and original functions better have flip-floppy things, right? So I'm going to maybe go back to the original function and say now this is all extra. This is a different problem. Totally fine. Totally possible problem, but the domain looks like it's going to be negative infinity to 1 united with 1 to infinity. And the range, if I remember anything that's right, there's a horizontal asymptote, right? Remember those things? So if I remember anything that's right, there's some horizontal asymptote somewhere. But it's going to be every other possible number. Because this function... What were you saying? Oh, okay. If we remember what the function looks like, and we haven't technically learned horizontal asymptotes yet, so the range might be out of our scope. because horizontal asymptotes is this whole thing where you go like 2x over x and you cross out the x's and it's at y equals 2. Which, hey, look, there's that x, better not be 2. But we do know that the function looks something like that or that, right? So if the function looks something like that, there's only one bad number for the range. It's there with whatever vertical shift it is getting applied. I don't know that you're responsible for the range of rational functions yet, though, since we haven't learned it. But definitely the domain you're responsible for because of that. But I don't know that the range is true. Though we can tell the range from our other domain. I can tell you the range from right here. That the range is going to be negative infinity to 2. Negative 2 or regular 2? Regular 2. United with 2 to infinity, right? And likewise, the range down here, for the inverse, the domain and range are just going to be switched, right? The domain's going to be the 2 infinities, and the range is going to be the 1s. Because the domain and range are switches. Just some side notes. Not what it asked for, but pretty cool. Yep. How do we know that f has an inverse? That is a good question. Maybe 2 different ways. There's actually, there are 2 different ways. That's fun. This is really a sad day for me. I don't know what I could do to solve this problem, but right-clicking is not an option anymore. It's not broken. It works. Look, watch this. Right-click. Works just fine. Just this app decided you're not allowed to copy and paste it anymore. Maybe they're trying to get me to buy the premium version. They're always trying to get me to buy the premium version. Look at this. If I even click on this line tool and try to change it. Nope. Hey, look at this. Look at how cool this is. You want a split screen? You want a math stuff? They even have a math section. Pro Plus.
They have a math section?
Yeah, look.
They really trying to get you.
I know. Wait, where's... Oh, there it is. You see that? Equation editor? Look at that. You just write the equation. And boom, pops up that quadratic formula for you. Nah, yeah, I just think teaching. All right, here we go. Inverse. How do we know it has an inverse? Well, I mean, first we got to know what the function is. Any thoughts on the function? Subtract 2, cube the result. So f of x subtract 2. The whole thing? Feels like the result means the whole thing. Okay, how do we know that has an inverse? I'll tell you right now, the easier way to tell me it has an inverse is because from the first day of school, you memorize what the toolkit function is, right? And so what is this? What's the only shift that's happening to this? Horizontal shift to the right by 2? So that red function does something really nice and neat. What does it do? What's really cool about both of those functions? They pass the horizontal line test. That's what that blue thing's showing. Those arrows don't matter. Horizontal line test, check mark, which means they're 1-to-1, which means they are invertible is a cool word to use, but you could say has an inverse. So that's one way you can show. You can say, I know what that function looks like. It's a cubic function shifted to the right 2. The cubic function's invertible. Boom. What's another way you could show? It's a little more mathy. Anybody remember this way?
Do f of g, and then you would do g of x.
Oh, but then we'd have to find the inverse first. That's so annoying, but we could do it. Yeah, it's really annoying, but we'll do it. I'll do it. We got to find the inverse, so that's going to be y. Nope. Yeah, y equals cubic. Switch x and y, right? X equals y minus 2 cubed. This is the inverse step. And then we got to move all the stuff around, right? And if you do really, really good math, you're going to end up with the inverse is equal to the cube root. Oops, way too large. The cube root of x plus 2. And we can call that g if you want to. But then we can use that old formula of f of g of x better equal x, which better equal g of f of x. And plug and chug to find it. Is there another way to prove invertibility? I feel like there was another thing we talked about, but I can't remember. I mean, just solving for the inverse alone really tells you a lot. There's only going to be one bad thing in the solving for the inverse that tells you not invertible, and that's a plus or minus sign. Plus or minus sign is the no-go for inverses. And since we didn't have a plus or minus sign because it's cubic, and cubics don't have plus or minus, because negative 2 cubed is negative 8. But wait, what about 2 cubed? Okay, that's fine. Okay, wait, what about 2? Wait, that is 2. What was I thinking of to help prove my point?
I don't know.
Here's a I, right?
Not right here. This is true. What I've done so far? Pretty darn true. What about... I've forgotten what the point was.
Oh, but I think you're talking about square then? Because
We could say squared. 2 squared is... Well, negative 2 squared is 4. And 2 squared is 4, right? So those are different. And now if you were to go backwards, what's the cube root of 8?
2.
Could it be question mark negative 2?
Because it's positive.
No, because it's positive, and negative 2 times negative 2 times negative 2 is actually negative 8, not 8, right? So it's not like the square root where you have an option and you don't know. You do know. Negatives turn into negatives, positive turns into positive with the cubic function. That's why we don't have that plus or that minus sign with the cubic.
Not working.
Yeah, it doesn't like you.
Maybe it's like this. Wait,
Wait, you delete the whole thing.
yeah.
It's not.
Look. It works now. But you have to have the hand selected. But I can't write if I have the hand selected. That feels wrong. The mouse and the hand should do different. Okay, well, sorry, this is not your problem. This is my problem. All right, what are we working on next? I don't need this anymore. Heck yeah. What's up? With the third part?
Yes.
Yeah, that's fair. Full disclosure, I haven't done this yet, so let's see how it plays out. Well, do you have a specific question before we start it?
No, it was just I don't know how to do the last part to find the slope for precalculus.
Gotcha. Wait, you're talking about number 9? So this one?
Yeah.
To find the slope?
No.
Oh.
There's. Wait, let me.
So what's f of a plus 2? You know where to start at least? Square root of? That's so much nicer when they give you an A and not an X. You know how sometimes they give you that X plus 2 there and people get a little, like, I don't like plugging X plus 2 in for X. It's allowed. That mostly happens with that f of x minus h plus f of a, or x of x plus a, x minus a.
What are you trying?
What's the formula? Someone remember that formula?
It's x minus. Wait, x plus. Are you trying to like be x plus h or minus h? Or
Plus h minus f of. Yeah. Look at y'all. I was testing y'all. That difference quotient. This concept happens a lot in the difference quotient. That's where you got to be good at plugging and chugging formulas. That's kind of where this comes from, even though this is from like section 1. This is a concept that's from section 1, so it feels harder than it is. It's actually pretty darn easy. What goes on the bottom? A plus 2 plus 1. And so to wrap up the whole thing, we're just going to combine the like terms, a plus 3, and call it a day. You can't do anything any further. Knowing when to stop is one of the harder parts of math than doing the math part. Knowing like, because it feels like, oh, well, I should cancel some A's. You can't. Different exponents. Oh yeah, we can do the domain.
And then what's the average of change in the f between x?
Wait, what?
There's a part D.
They are part on the back, ABC.
well, because you have to plug in 2 and 10.
Determine the domain of f. What is the f? Oh, were you asking for the average rate of change?
Yes.
Oh, well, you should have said something a long time ago. Yeah, that has nothing to do with the A's up there. Well, you can do the domain. Domain has 2 bad numbers. Crap, I need to, hang on. Give me a second.
Then, like, it's, whenever they ask the average of change like that, we have to solve for all 3, like 0, 2, and 8 plus 2.
No.
You just have to plug in the x's they give us.
Correct.
And then find the y.
These are 3 different problems. A, B, and C are 3
Yeah,
different
like
problems.
I said, though, I have to plug in to find the y for 3 problem. Right?
No. Average rate of change means kind of slope. It means you got a weird curvy function. An average rate of change strictly means you pick 2 random points and you ask yourself, what's the approximate slope between those 2 random points? Guesstimating slope. Average slope even. So the function they gave us was,
Oh, it's square root of x over x plus 1.
and we're going from the red point. Now that's not what this function looks like, I promise. But I'm just going to pretend like it is for the sake of the problem. What's the first point they ask us to go from?
From 2 to
2, comma, what? No, we don't know that yet. 2, comma, we don't know. To where?
10,
10, comma, we don't. I know some of you know, but 10, comma, we don't know.
I don't know.
And then, but this is the cool thing about looking at it this way, is we're determining the average rate of change, and we've already talked about that's pretty darn similar to slope. ... It looks kind of similar. So instead of memorizing the formula for average rate of change, what was the slope formula from our life?
X minus x1.
Y minus
Y2 minus Y1 over. And we've already got our X2 minus X1 up above, right? Going to be 10 minus 2. And so now we just got to find those 2 blue numbers right there. Plug and chug. So it feels like it's going to be root 2 over 3. That's ugly.
And then it's root 10 over 11. Ew.
That's okay.
No, it isn't. It's gross.
And then we subtract those 2 things. Root 10 over 11 minus root 2 over 3.
Gross.
Is that not right?
It's right, but it's gross.
What? Yo, that's not even that bad.
Sure.
Wait, pause. That was a lot of groaning.
Look at it.
Okay, other than the ugliness of the numbers, is the plug and chug the hard part? What are we talking about?
No, it's just the ugly numbers. It's just like, because then you have to try to figure out how you can subtract that.
Well, let's do the easy stuff first. Look at the bottom.
Alright.
Leave the top alone. And let's just get that bottom down to one nice, neat number. 8. That's not the hard part. That's what everybody's saying. Okay. Any thoughts? Anybody have a? There's two ways you could really go about this, and I don't think any's easier or harder. You could send the 8 up. You could send the 8 up, or you could leave the 8 for now and get a common denominator across here.
Can you send like the 3 and the 11 to the top potentially?
That's kind of how we get a common denominator.
Like, cause I mean, like, so multiply by the reciprocal for those two.
Right.
So like it'd be 11 times the square root of 10.
Like that?
I guess it.
Oh, yes.
Are you allowed to multiply by 1 willy-nilly wherever you want to? Yeah. So we just multiply by 1 a couple times. And so now we're looking at 3 root 10 minus 11 root 2 over 33.
Over 8.
Over.
Yeah. And that second over sign is bigger than the first, right? It's really important to know the order of operations that's happening.
So it's gonna be negative.
So 3.
So now we're looking at
Wait, how did?
Square root.
keep the top,
Change.
keep the top, change,
And flip.
flip, turns into 1 over 8, right? So we're looking at 3 root 10 minus 11 root 2 over 33 times 1 over 8.
Wouldn't it be simpler if we simplify the top first and then?
I don't think we can simplify the top. Oh my
Yes.
goodness.
Because it's negative. I mean, square root 10 is.
Actually, I don't think we can. 11 doesn't divide by 3.
No, like you can. So the square roots aren't the same.
Correct. And not only are the square roots not the same, the square roots can't be broken into anything that's square rootable. 5 and 2 is not square rootable, and so we have to leave 10 alone.
Okay.
Oh, wait. Okay, this is not simpler, but you're allowed to. What if you did 3, 5, 2, 11, 2, and then yank the 2 out of there just for fun, so you got root 2 times 3 root 5 minus 11? Not simpler. You don't have to do that. That's just if you're tracking with math. Don't do that. That's not easier. It's just allowable. Let's just finish this off. 3 root 10. Anybody got that calculator problem for me? Because I don't know it.
Well, you say it's not calculator in that question.
Okay, well, this is just a hard version of an easy problem. It's going to be 1s and 2s later.
Yeah, like.
What's 8 times? Okay, fine. You're right. It's not calculator. I'm sorry. You can do single digit multiplication. Grow up. You're in college.
He's so aggressive.
Well, don't complain. 264? Yeah. Okay, cool. It is. You're right. It's not calculator. Go learn how to multiply single digit numbers.
Not gonna come up with that.
That's fine. That's a great answer to a great problem.
Yeah, put everyone's around great.
Great problem.
You think it is?
I think it's a pretty darn good problem, actually.
What do you think, Seth?
I think you got to know how. There is a section if you're like, I don't get any of that, and I don't think it's going to like teach you the whole thing in full. You could go to YouTube or Khan Academy or whatever for that. But if you go here and you go to hard topics, nobody likes this. This is what we just did, rationalizing the denominator. So there's an example with practice problems on my website of just, hey, here's the foundations of what we just did, kind of with the square root stuff, and some practice problems, easier and harder. And then I think I do also keep, change, flip, that we just did that as well. Some exponent laws, which there are a few of those that popped up in there, right? Maybe not so much. But those are another hard thing people don't like. So if you go to my website, and if you have any more domain and range, look at that. I didn't even know that was there. Look at that. Oh, it's not. It's distributed property. Joke's on y'all. There's no domain and range. Yeah. So more stuff if you want it. Just let me know. But if there are the rationalizing the denominator, we should do and keep, change, flip, which we just used. Perhaps we should have what did we just do that was kind of hard? Common denominator type thing. Yeah. I know I know that's kind of a sort point of contention with a lot of people. Yeah, I don't have one in here. But I do have that little thing that we did where in red, I left it red. So technically we're just multiplying by 1 when we're trying to get a common denominator, right? You're always allowed to technically just multiply by 1. That's an allowable thing. All right, let's back to it. Zoop. Yo.
So how do you know when to stop? Because that last problem, like I would just spent the entire time trying to figure something out.
Oh, like this?
Yeah, because like that doesn't look like an answer, you know?
That is, yeah, that's fair. It's a good question. I think that there's two types of problems. This is one of them. The other one's going to have like your 2x's plus your root x's and stuff. And some people try to combine those two things, the x and the root x. So there's two types of problems. One is a numerical problem, only numbers. That's what we just looked at. One is a variable problem, which has either 1, 2, or 3 variables with 1, 2, or 3 exponents. And that's kind of what's looking down here. The easier one for me to answer that question for is the exponent one. Because everything is going to have different variables and different exponents, and then you stop. When every single thing on your paper has different variables and different exponents, you stop. So for instance, this is different. Same variable, but technically the square root is a 1/2, and so we've got two different exponents, we stop. Right? That's the simplest answer for that is no like terms. You've done all of the combining like terms that you can. That's when you stop for that one. Here's a little different because it assumes properties of radicals and knowing when two radicals can and can't be combined, which is really not easy. Radicals can and can't be combined when you've broken it down like with that 10 and gone 5, 2, there's no more perfect squares. If it would have been a 20, we got some work to do. Yeah. Because 4 and 5, we can take the 4, exit out, and put a 2 on the outside, right? And that would be like 2 root 5, I think.
We would still go like 6 root 5 minus 11 root 2. And then,
6 root 5?
right, because you take the 2 out.
Oh, if it were 20?
Yeah.
Sure. And then we could figure out if there's a way that it works. If it were 6 root 5, 11 root 2, those still don't combine. Yeah. So we'll just leave it there. It's just being careful that you can't combine square roots unless they're exactly the same. Almost like variables. Unless the square roots are exactly the same, that's 2 root x. But if the square roots aren't exactly the same, kind of just leave them where they're at. And that's not too different from denominators. Unless denominators can be factored to be exactly the same as the 2 numerator, you can't do anything with it, right? Unless you can break that 264 up into an a and a b where one of those factors, you really can't do much with it. Like it's just hanging out there as an ugly mutually prime numbers where 2, 11, and 264 are mutually prime or prime as it with respect to each other. Okay. I don't have long answer for I don't have an easy answer. It's just hopefully you don't encounter something that tough. You won't, I promise. It's going to be 1s, 2s, and 3s.
That's not gonna be anything like that on the test.
The math, yes. The hard numbers, hopefully not.
I'm talking about like the hard number with
Who makes the
square
who makes
root.
the test?
I don't know. Just the universe.
I'm not talking about the fine. I'm talking about what you're even doing. It's not gonna have that crazy.
I don't know, man. You never know.
You do that.
Let's go. What you got? Thank you. 11b? Boop. Boop. Watch this, y'all. I've got it down now. Hand, right click, paste, zoom out, shrink a little, move up. Click. Don't forget to click back on the marker. All right, we're looking at increasing and decreasing. You cool by doing increasing in green?
Which is it's negative.
Well, hang on. Let's just shade them first. There?
Yeah.
You cool with that? Okay. And there? Hop over to orange. Just because it's already red and that might be confusing. There?
That's not orange. That's yellow.
I know, it's a projector. Additive colors versus subtractive colors. Pretty cool thing to learn about. CMY. You know how some things say like CMY or CM. There's another color. Cyan, magenta, yellow. There's another one. But then some say RGB.
Yeah.
There's this thing, printers and screens and additive and subtractive color. It's really cool. Just look it up. Wavelengths,
Well,
physics.
CMY is-
I don't know. Okay, what are we doing here?
It's a interval.
So the green one starts at, I don't know.
Well, that'll be
Negative 6.
1, 2, 3, 4, 5. Kind of doesn't look like it's all the way to the line, if we're being honest.
well, that'll be 7.
Negative 7.
1, 2, 3, 4, 5,
6.
5.5, I think.
No,
Wait,
would it be negative?
No.
Am I crazy?
It's right there.
Because
But
it-
Y'all.
it's right there.
1.5, 2.5, 3.5, 4. Hang on, stop. 1, 2, 3, 4, 5.
It's like 5.
You
It's not 6. That would be.
Yes, it is.
You think that's supposed to be a whole line right there?
It could, yes. It could. It's infinity.
I say 5 seconds 5.
Yeah. You think all those squares are the exact same size? Also, it's not touching that line?
It's not touching either one.
Hey. I say 5.5, y'all.
5.
Okay, here's the real way we can know. This is so pointless.
Well, but you want us to be as exact as possible.
That looks like it's about halfway, right? Not halfway of that square, halfway of all the squares.
575, like he said.
That's what I'm saying.
Do you want?
575 because it's over.
Fine.
Do you want us to be as specific as?
Someone said 7, so that's just easy.
I said 7.
Is that first you
And where does it stop at? Be careful.
4.
Or
Okay. A lot of times I've seen, because I'm just
Negative 4.
negative?
thank you. I've seen students get rolling on, I'm writing a point. Cool, because they just drew soft brackets and then they accidentally write this number right here. And it's like, oh crap. You just looked at that and thought point. It's not, it's an interval, right? The second one is a little easier to do. We don't have to argue about this one. It's going to be -1 to 3, it looks like.
Well, when they be on the same thing.
What? It's right there, right?
Well, no, I mean, because when it be like -5.75 for you.
Oh, yeah. So now we're going to stop at -4 and we're going to go all the way to -1. This is decreasing. And then we're going to go from, then we'll get to argue again here, but whatever. 3 to
That's
2, 3, 4, 5, 5,
That's
5.3-ish.
sure. Let's just go
It's
with
okay.
that.
It'll be on a dot. This is just drawn Google graphs so you can see what's going on.
But like, so how would like if we would need to draw like as like a union or no?
No.
No, because there are.
It's not asking for a domain of total numbers. It's just saying, what are the intervals where it's increasing? So it's kind of different thing. If it said, give a domain, or I don't know. No, don't worry about that.
The actual turning points, they're always different.
You can go and find different textbooks that'll say different things. And so you won't be counted off for brackets or not brackets. I think on my open math, it was no brackets, right? Well, on the homework modules, it was all open brackets, right? Okay, on the textbook of OpenStax, it's all open brackets. On the textbook we used last year, and another teacher used in college algebra, it was either or, and it said neither are right. And then I went and Googled just like 4 or 5 different college algebra and pre-cal textbooks, and nobody agrees. But everybody agrees. It's just report the interval. Because is it decreasing or increasing on this point is a fun topic to talk about.
The slope is 0. Like at that 1 point,
Right, but you could always build a limit that zooms in and includes a little slopey section really close to that 0, right? If you were to stop it before, if you were to stop the interval before that -4, right? Like at 3.99999, we could always find a closer number. So you got to include that 4. But which one do you include it on? neither or both, or both doesn't make sense because it can't be increasing and decreasing. You're right. It's a turning point. What's up?
The increasing point, is it -1, -3? Because we have a -1.
That's a good question. You're asking about this range right here? Okay. So, and where did we get that range from? This second green thing?
Yeah.
Correct. And this is the first starting point. This is where this line right here is where we got the -1 from. Okay. This blue line gives us this blue number. And this red line gives us where it stops. That's where it stopped increasing. And that number is +3. We're looking at x values of increasing. We don't even care about the y values. So we're looking at the x. What x value does it start increasing? What x value does it stop increasing? What x value does it start decreasing? What x value does it start? Perhaps a better word for interval is find the x value limits, if you like that word. Boundaries, if you like that word. Or just x values where it's increasing and x values where it's decreasing. It's a nice way to think about it. Boundaries is a nice way to think about it too.
So it's on A,
Mm-hmm.
like it's the same problem, but it's A. So the minimum I do is -4 and the maximum is 3.
The minimum is y equals -4. The maximum is, I think it's 4.
No, I'm sorry. 1, 2, 3, 4. Y equals 4.
At. Oh, and find where they occur at. At. It looks like -1.
-1.
X equals -1.
And then
At x equals 3.
Okay.
Yes. I don't think it touches it.
That's the reason why I was like wondering if either that or the other.
Egad. Egad. You're talking about. It was too highlighted for me to see. No, wait. What?
Everything shifted.
What?
Oh,
Oh.
thank you. I was like, what the hell is going on?
You accidentally selected everything.
Yeah. You're talking about this point right here? -4? Wait, no.
About the negative.
-4, -1? Oh, for relative? That's not an absolute. Does it ask us for? Oh, yeah. Local means we need to find those two. So these are the absolute answers. If it asks you for that, I just assumed that's what you were asking.
Just leave like that.
And locals are going to be -4, -1. Max. 3, is it 4 or 5?
Okay, so
I don't. Hang on.
before anything, shouldn't you write it the other way?
Sure. I was just trying to
No,
say.
because you putting -4 in the x position and -1 in the y position.
Local max at. Local max at.
Thirds.
What?
It's
It's 3, 4. That is the local max. Isn't it?
3, 4?
Yeah.
So local max would be y equals 4 at x equals 3, also known as 3, 4. And y equals -1 at x equals -4.
That is the minimum.
Yes.
No, that's a local maximum. Because if you zoom in big enough, it
Okay,
looks
okay,
like a
got it.
max.
Okay, I got it. No.
Is the thought of a maximum?
-4 to -1.
The complete thought behind a maximum is if you zoom in big enough
Okay.
and delete everything else in the world, it looks like a maximum value.
Okay, so it's 2 different.
Would it be wrong if I put all of the points that are like max and all of the points that are min?
No, it says local. I didn't see that at first. Actually, it's the only right thing. We did, when we learned it, though, realize that endpoints are not local maxes. Just so you know. They are thought about for absolute value.
So we don't put them for
No, you
max
don't put
or
endpoints in locals. If it asks you for absolute, you have to consider them. But for local, no. Not even. We did some research during class trying to figure out Is it work or not? I don't remember. What were the other ones? So I don't just leave it short. This would be the point 4, negative 4, comma, negative 1. Is there another local? There's the local min in the middle, right? At y equals negative 4 at x equals negative 1. So that would be negative 1, comma, negative 4, and that's min. Is there another local min, or is that it?
That's it.
3. There's 3 turnarounds. Yep. Boop. Two o'clock. Take a little 5-minute break. Stretch your legs. Let brain come to oxygen. Go outside. Get some fresh air. You don't have to, but it's good for your brain and let your brain get some fresh air. Take a 5-minute break. We'll get back to it. All right. Had a second question about this triple composite function, right? Sometimes that's annoying. Personally, they're my favorite because you get to go a little slower and be a little more careful. G of G of G of X is what that stands for, right? I can't remember. Do we start on the inside or the outside?
The inside.
I know you're allowed to do either, just depending on what you like to visualize it as. But I prefer starting on the inside. So I'm going to take that G of X and replace it, which means I'm going to be left with G of U. Close them all up. Okay. This is where, yes, here's an example. We were talking about earlier. When it's a plus 2, everybody's cool. When it's x minus 3, everybody loses their minds. Right? So what are we doing with that x minus 3?
You're plugging it into G.
Plugging that. Plug x. Wait.
Wait.
No, we're good. We're good. This is right.
No. It's in. So you gotta leave it like G of G and G like that.
Well, no, I'm going to keep going.
No, because it's like in the. I saw the test review that you go on online. You change it to G of X and X of G. So that's.
I don't know what you're talking about.
It's.
I trust you, but let's just finish it. We're halfway there. We're plugging x minus 3 into x, right?
Okay.
Which means we've got G of x minus 3, what? Minus 3. Amen. And before we do another G thing, let's combine like terms. So we've got G of x minus 3, which is just G of x minus 6. And now we are going to repeat. We'll plug x minus 6 into x. I guess I should have said G of x. Same thing up here, G of x. And so now we've got ourselves x minus 6 minus 3. And so long term, we're getting triple G is actually just x minus 9. G of x equal. Oh, crap. These should all have x's next to them. That is my bad on formatting for the review. If you're looking at these, I mean, it's okay. Except for that one. No, those don't, because those have a 2 there, right? This one should have an x. You might want to fix that. My fault. Super my fault. Now, sometimes you see it this way and it doesn't have an x. I've seen that in a textbook before. But if they give you those parentheses, they better give you those just in terms of formatting. The problem doesn't change. It doesn't change how you solve it. I'm not saying this is like a new thing. It's just these are the 2 formats. Either straight up with no x's, saying combine the 2 functions, or, hey, I'm giving you the variable. Answer's the same, just so you know what to be looking for. It's very fun. I know what you're talking about. On the test, I went outside in instead of inside. Or on the test review, I went outside in instead of inside out. And I think what I did is I said G. Well, actually, no. I just started with big O x minus 3. And that's the outside G. Right? Inside G. No, I went blank minus 3. Right? And then farthest inside G, I went x minus 3. So that's how you can kind of visualize what's actually happening here.
Oh,
Okay.
That is a pretty visualization of what's happening here. You like that better? Okay. I should have followed you, Eddie. Thank you for saying something. If you want to make it even prettier, we're going to change those boxes into parentheses now. Makes our life even cooler. Right? It just got a little more mathy, right? And without the colors, it's even worse. Your brain's like, oh, crap. Without the colors, I'm like, sunk. But that is a real good way to visualize it. Knowing that those parentheses go away pretty darn fast, working from the inside out. Can't do anything else with x minus 3, so I rope in the next one, which makes it x minus 6. Can't do anything else with x minus 6, so I rope in the next one, which makes it x minus 9.
Also, I think we forgot to
What?
roll. Because did you ever take roll?
No. Take it at the end.
Oh, yeah.
No, I'm just kidding. I just forgot. That's a pretty way to visualize that? Okay. Every time. I mean, that's just basically our brains looking at a f of x and knowing that's not like anything. X isn't anything. X is just a random placeholder for whatever happens. That's really just like blank squared minus 2 times the same square plus 3, right? Totally a normal way to visualize / think about a function. And that function would probably be x squared minus 2x plus 3. Pretty common function. Those blanks are a good way to visualize variables if your brain is having a hard time really seeing what's... Nobody cares about the x. The x is pointless. The x holds no weight. The x is just a placeholder for something better later. Kind of like that open box is. All right, what else we got?
Can I see the
No. Wait, what'd you say?
Can I see the
Sure. You want this one?
No.
What?
There you go.
That's crazy. This one's way better. G of x is equal to that. What? Okay. Yeah.
So can we inverse one of the quadratic or like the square root?
Invert a square root?
Yeah, because I know the domain is really.
Yeah. Let's do it. F of x equals the root of x plus 1. That's fine, huh? I mean, maybe let's do plus 2. Or let's do minus, so we have both signs. So that is a function that we all should be able to graph. And if you can't graph it, what can you do? Plug and chug as many points as... Heck, I think on a test, I'm not even going to tell you plug and chug these 5 points or those 5 points. On a test, you know what they're going to give you for plotting? No, they won't give you the points. I wish. That would be even nicer. That would be the nicest. But on a test, they're going to give you... No. Well, yeah. But on a test, kind of like on the note sets, if anybody's ever given you a function to graph, unless they're giving you a blank white piece of paper, which would be awful, but maybe it's possible. But like on the note sets, if you're working through something, what do we end with? Like, I don't know, did we graph on 1.7? Probably not. Oh, we did. Look right here. So at the most, how many plug and chugs do you have to do? At the most, 20. That's a lot, but that's not too many for a test. You're taking a test. Do your diligence. Chances are you'll get off the map way sooner than you'll get 20. At the most, you got 20 plug and chugs. Start with 0, work your way out as it gets harder. 0, then do the 1s, then do the 2s, then do the 3s. See if you see the pattern. Or know the function. So what is the... Instead of that, we can actually know the function, which is... The original looks like that. And what are we doing to that function? Down 2, but then to the left 1. Ooh, that's hard. So what number is that? So that would be 1, 2, 1. So down here at -1, comma, -2. And then it goes up and over 1, because that's just what the square root function does. So we're going to end up on 0, comma, -1. I think, right? Now I'm just plugging in checking points. 0, comma, -1. Do I need to go to the left? Do I need to try -2? Because our brains know what this function looks like. We know it's going to look like the square root. So I'm going to keep going with 1. 1 gives us an ugly number that we don't know. That's okay. 2 gives us an ugly number that we don't know. 3 gives us 4 rooted. There it is. There it is. 1, 2, 3. That's the next pretty number. And I think we're groovy for... You were asking us to inverse it, though. But that's a good problem, too. Graphing that is super possible. I don't know what the next nicety number is, but it's probably off the graph.
It has to be 9, so it's like 8.
8. Well, okay, maybe not off the graph. Yeah, 8 plus 1 is 9. Rooted is 3. Turns into 1. You. Way over here somewhere. 4, 5, 6, 7, 8. Not bad. They'll give you the graph, though, so you don't have to do what I did. All ugly like. Let's invert it. Step 1 for inversing someone besides. Oh, just writing the y. And then anyone but Nehemiah. Switch them. Love it. Next. Next. Careful, careful, careful. 2 careful things. 1, don't just put the square there. What do we need when we're adding that square over? Parentheses. Cool. Then there's a second careful thing to be mentioned.
Wait, the square root is gone.
I know.
You subtract 1.
Well, this is just a fun little tidbit for everybody on their phones and TikTok and whatnot. Do you know the most common mistake is right here? Most common mistake in the world? Super common mistake. X squared plus 4 is the most common mistake that I've ever seen. Honestly, no matter what class. You go to Cal 3, you go to this class, you go to 9th grade Algebra 1, because they still kind of do this. A little, not as hard, but yeah. There's that intermediate step that I like to call FOIL, but everybody has a different word for it. X squared plus 4x plus 4. Though, honestly, it's easier to leave it, I think. That's true. Plus 1, and then move it over, and you get y equals x squared plus 4x plus 3. Oh, that's fun. Oh, well, maybe it's not easier to leave it. That's fun, too. What is that? Y equals x plus 3x plus 1? You know what those 2 things are? Those are zeros. We haven't done this yet. We haven't done this in class yet, but those are zeros. Well, no, that's wrong. Hey, thank you. Those are our factors, and factors tell you the zeros because the zeros are actually x equals and x equals, which means the x-intercepts are, what's an x-intercept? Hey, say it the right way. And 1, 0. Okay, that's just side notes. We're doing a bunch of side notes. This is good, though. This is math studying is. You asked a really different question. We've gone down like 6 tangents on the way to that question. But I think that's math. That's what, I don't know. That's a better way to do math is just to let's just see what we know. Not, let's go find that inverse right now and find only that inverse. Yeah, let's finish this and then I'll tangent. So we got x-intercepts. That's fun. We got zeros. We reminded ourselves that if it's a factor, it's a 0. We probably could have not done that. Watch this. Side note, let's not do that. Someone was saying to do it and I didn't. I didn't listen to you. Someone was saying just move that 1 right now, earlier. So that would be y equals x plus 2 squared minus 1. That's easier to graph. Yeah. Way easier to grasp. But I think what we did was really cool. So now let's graph that. Regular parabola, except for it's down 1 and left 2. And then it goes up and over 1. What point is that? Negative 1 comma 0? Egad. It's almost like math. And that point should be. What a crazy world we live in. So cool. Okay, I'm not doing the rest. Actually, we should do the y-intercept. We know the y-intercept. That was cool. Don't do that. There's the y-intercept, right?
Yes.
So it's probably at 3. And if you're really cool, you know about axes of symmetries, and you can flip it over here and go over 1 up 3 and figure it out. What were we doing? Oh. Well, there's the inverse, right?
Yeah.
But it's not. We got to kill half of it. And we got to pick the half to kill, right? Okay. Well, you know what we got to do to figure out the half to kill? Go up here to our old graph and say, what half did we kill there? It looks like we killed, right? The green was our graph, right? Okay, so ignore the other 2 lines. It looks like we killed everything down here, right? Right? Well, what are those numbers? What are the numbers that got killed? It doesn't make sense to use the x-axis because technically doesn't that go on forever with x? Like you could just keep going over with as the x goes over, and it's like, well, and there's not really any number to pick if you went upwards towards the x-axis. So we got to use the y-axis for figuring that out. Yeah. So what numbers? What is the range of the green? No, the range of the green is -2 to infinity. Probably including 2 though, because it's a square root function. Which means we killed what section? -infinity to 2? To -2? Let's go over here and see which one of those makes more sense. So what section of this are we probably destroying? The same destroyed section, just so you know. So what section got destroyed on the y? The negative stuff? We're killing all that negative stuff. And there's your new domain, which would be, this is your inverse. Your inverse is 100% f inverse equals x plus 2 squared minus 1 with the domain restriction of -2 to infinity and a range of -1 to infinity.
Another way to find the graph without doing the work beforehand is just getting the graph before I'm flipping the point.
Yep, over that line. Yeah. Another way you can think about it is, was it right here? Did it look kind of like that? I don't remember 100%. It was at -2 though, right? So it looked kind of like that. Each of those points just got flipped across that line. It's just a little harder to see if you're not a good drawer like me. Like, that's not a perfect flip. So it gets looking ugly once you do all the stuff in the same graph, though. I understand that. You are right, though. 100% you could just go flip it. Or if you even wanted to be a little carefuler, you plugged and chugged points up here because we got a little nervous. See all those green plug and chug points? You know what you could immediately do is you start with your inverse. Take all those points and start plugging and chugging the flips. These are all on the inverse. And if you flip all of them, even the ones you don't know, I still don't know it. But the ones you do know are going to show up there. That's fun. It's almost like the domain and the range swapped. Zoom out. That's a lot of work. It wasn't that much, though. Just a lot of talking through stuff. Good question, though, even though it's not technically speaking on there. What else are we looking at? Everybody's great on number 2. Nobody's even asked for number 2. I'm not saying we're doing it. I'm just saying
Well, number 2 because you already reviewed it last time whenever I asked.
we've done it a couple times.
Yeah.
Okay.
I have a question.
Still hard.
Do we have to use the point slope formula, or can we do
It will tell you which one. On each problem, it will tell you one or both or either. You don't have to use either. Just reporting the problem at the end.
Okay.
If you prefer to use a different one to get there, that's a good question. Is do you have to use the point slope or the slope intercept? You don't have to use either. Whatever way you get there. But you do have to report it in whatever they ask you for. Because I don't make these. So, for instance, these are straight off the test. And I guess they didn't ask you for any. Did they? Oh, right here. No, that's the... I didn't just skip it because I already don't know that. Write an equation in point slope. So you do have 2 there. It was very explicit which one to write it in.
For 10B, who are the ones that you know?
10B. Oh, yeah. That's a great question. I mean, I guess you could do 1 twice, but it's pointless. Yeah, that's probably a negative, huh? Thank you. Typo. 2B? Sure. Negative 3.
Wait, B or Z? You said
That's negative 3. D?
D.
Oh, yeah. 6x minus 4?
What? 2D?
Let's do it.
Why did you say 6?
Because next year, you'll be able to do that. Next year, you'll be able to do
I
that.
got 3H plus 6. It's 2D. That's what I'm talking about.
Let's do it. Did you get 6x minus 4 plus h? Or plus 4h or 2h or something?
X plus 3H minus 4?
Minus 4? Yep. 3h. There's always an h in there. The h goes away, but...
That's what I know. Let me do it.
All right, yeah, that's a good idea. Thank you. Float again. What are you talking about? Oh, yeah, that's pretty fine. She had a cool accent. We did in D. Let's pretend like you memorized the formula. I know we're saying it's going to give it to you, but let's just pretend. F of x plus h over h. I sent that picture, didn't I? On the group meet. Did anybody take a gander at that picture? Nobody? Okay. I thought it's a really cool pictorial representation of what's happening here. Pick a number, any number in the world. Okay, cool. I'm just going to pick a y value now. Okay, that's about 3,2, right? I just needed a place to start. Let's not call it 3,2. Let's call it x. What's the y value? Yes, we do. F of x. We all in agreement that that's a point. Okay, watch this. How far did I go over? 8. No, how far did I go over? That's the point. How far did I go over? You don't know. Let's call it a random variable. Should they have called it A? Maybe, but they call it H. We went over H. Who knows how big that is? 2, 3, 4? I don't know. So what's this point? X value. This X value now is X plus H, right? Which means that, hang on, I got to do this in blue. That means that this X value was X, right? And this Y value was F of X, right? And how high did I go? No, I'm going up now. So really, that's not a point. That's a turn. How high did I go? That's a harder question. But what is this point? F of x plus h, right? That's that point, right? And what's the formula for the average rate of change? Let's rise over run those 2 points. Oh, crap. I need this point. What's that red point? Right? Let's do some rise over run. Let's before we do that, let's label. Which one do you want to call x1? So we're doing x1, y1, x2, y2. So the first thing that goes on this formula is f of x minus 8 plus h, right? I know I just lost a lot of people. I know that's where it got a little.
Wait, are we doing?
It got dicey when we started throwing like 6 variables in the same thing. But you saw the drawing the whole time. We went point, go over a little bit. Different point, go up a little bit. Label that. Now we're just doing the freaking difference quotient or the what's it called? Average rate of change. That minus what? What do you have to minus? Y1? Minus y1, which is just f of x. Over. Well, don't do h. We're doing x2, which is minus. That x was blue. Well, this was blue too, actually. And now you get to cancel out some x's. And we've got ourselves a formula. If you know the slope. We don't know the slope for this one. Look at this one. It's a quadratic, right? But if you make, this is what's really cool. If you make h really, 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 really small, you know what you pretty much get? H is this number. Sorry, I should have said. If you make your difference, if you make h, if you make the distance between, like if you make, that's me driving down the road. I'm going fast, I'm going slow, I'm in traffic, whatever, right? That's my speed. If I do that, is that an accurate speed for every second of every day? Not really. It's just a speed. It's an average speed, but it's not accurate. But if I make h, this point right here, I need that point. If I want to make it h right here, the distance between the two greens is getting so small, right? I'm shrinking the distance. I'm shrinking the x distance between the points. Not the y. The y changes with the function. But the x distance is getting tiny. And if I make the x distance the tiniest thing in the world, you know what happened to my accuracy? That's pretty darn accurate to how fast I was going in that point, right? So what this whole difference quotient is an exercise in finding slope. Way easier with the line, way harder with the traffic equation. And so here we are saying, what's the slope at some point for the parabola that looks like that? Well, at one point it's going to be 0. At some point it's going to be positive, and at some point it's going to be negative. But we're going to find it anyways. We're going to find a formula to find it. And this is the formula to find it. So that's a lot of talking, I know. Let's get back to the actual solving. The blue equation is this equation, right? No, the blue equation is this equation, this bubble. Let's do the blue bubble first. We get 3. What goes into the x? Squared. Minus 4. What goes into the x? Do it again. Be careful. We're just doing the blue bubble. Plus 1? Minus. Hang on. Before I do minus, I'm going to give myself some nice big parentheses with the non-colored minus sign. And now we're doing the red bubble, right? What goes in the red parentheses, because that negative has to distribute? The original function, right? Okay, so this is f of x. This is f of x plus h. And I know there's an h on the bottom. I'm going to give that over h some space. Because we always got to do work on the top first. I know it's there. I know it's there. Giving it some space. We're going to come back to it. Now we got to do some math. I know, you hate math. If you get good at FOIL, you don't have to use as many lines in your paper. 3 parentheses x squared plus 2xh plus h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x minus 1.
And then cancel.
Well, what?
Hang on, I need to label these two things. I need to label FOIL. I need to label distribute. I need to label distribute. And I need to label a different color distribute to the FOIL. Right? Oh, I haven't done the red one yet?
Yeah.
Good call. So now we're at 3x squared. Hang on.
6xh plus 3h squared minus 4x minus 4. Blah, blah, blah.
I can write faster than you can. That's so much writing.
And then yours cancel.
And then
So many stuff cancels, right?
negative.
Hang on. Pause. If stuff doesn't cancel, at least 2 things, maybe 3, usually all of it. If stuff doesn't cancel, start over. It's going to cancel. I promise. That's the point of this problem. If it doesn't cancel, start over, please. Don't just manhandle a really long problem that's hard. Start over and see if you don't get those x squareds canceling. Especially the bigger exponents got to cancel. See if you don't get those 4x's canceling. Which leaves us with 6xh plus 3 all over.
Well, so now it's over h still, because remember there's still that h down there.
No. That is that h.
Oh.
That was that green.
You just put it lower. So
Yeah, I
you
know.
see it.
I put it lower because I wanted to work on the top first. I should have put it there and rewritten it every time. I'm lazy. Don't do what I do.
So then we can cancel the h, some of the h's out. Because that'll be 6x.
How did you just cancel?
Well, you can actually factor out.
Everybody's so flippant with these denominators. It's hard.
Okay,
When
so
you
first,
divide, you
actually,
subtract the exponent from
But how do you know which one it goes to of the 3?
All 3 because they have H.
Not when you're looking at a function like this. What do you do there?
There's no H in the
So what do you have to do?
Multiply.
Factor what?
factor out an a.
What do you mean factor out? What?
No, so like h has an exponent to the first power, right? And
Sure.
then the exponent rule says that when you divide, you can subtract exponents.
Right, I'm cool with the exponent rules. What I'm not cool with is distributing or figuring out how which of those terms that h goes to. Like doing this. What I'm trying to say is I get this a lot. A lot. What? I agree it's not okay, but I get it a lot. Like,
Because there's only one H there, so you cancel
So it's
out
gonna be
H.
factor
There's
H.
I'm just saying I get this a lot, and I want to know why. It worked that time. Remember earlier? I don't know.
But you're
Um,
wording it.
I want to know why I'm allowed to just start going, cancel one of those, cancel that one. But why does the bottom need an H in each term?
Why not?
I don't know. I just want to see the math happen. I don't want to see the shortcut happen. Because the shortcut tricks people who can't use the shortcut. So the math that's happening, are we about to have to be done or something? Yeah, I didn't take a roll. The math that's happening, this is the most common mistake I've ever seen. Most common mistake, especially on test 1. This is it. The math that's happening is this right here. Zoop, zoop, zoop. Right? H, and now we're left with what? X? Oh, I'm dumb.
Plus 3H minus 4.
That's the math that's happening when you use the exponent rules that say the bottom bigger stays on the bottom, top bigger stays on the top, whatever they're called, exponent properties. That's the math that's happening. H and H don't cancel. What do? They divide to turn into 1, right? We do ignore the 1. I know we call it canceling. They're not canceling. They're turning into 1.
So that's okay.
That's
okay.
yeah. That is the math behind the shortcut of everybody going H, one of those H's, one of those H's. That's what's happening there. People just don't like. Sometimes we mess up when we have like the thing that would scare me is and would happen a lot is you've got 6xh plus 3 no h's plus 2h squared maybe over h. Now people really want to cancel but can't. 1 and 1, it's like you're 1 and 1. People are like, oh yeah, I can't do it. I need to figure something, but I can't do it. When you get 2 out of 3, people are like, I really want to cancel that h, and you can't, right?
So that's the acceptable answer right here, right? You can't do it again.
Final answer. Don't leave. I gotta take a roll. Final answer probably is gonna be.
Plus 3h minus 4. Okay, so I put the minus here. I should leave the.
Oh, when stuff doesn't cancel out, you want to leave the H at the bottom.
It's gonna cancel out.
I mean, look, say the last number is like.
Oh yes.
See, because my head, I wanted like.
Nope. If it don't have all terms, you don't have all terms. You gotta leave it. All right. Let me check roll. I also want to remind you the most. Let us record and let us begin a long day of review. Before we do, I think 3 things. First thing, Wednesday. Test. You need to bring a calculator, right? I think I sent a picture of it in GroupMe. If you have one, does anybody have one right now? Like the one that you can bring? It can't be, I know this stinks, but it can't be a grapher. That's perfect. Hold that up real big. Hold those, perfect. That little blue and light blue one, perfect example. That one's perfect example. They're at Walmart, Target, Walgreens, wherever you go, you can find them for about $11. If $11 is insane, let me know. Come talk to me. Come to office hours. We'll figure something out. Even if it's not insane, there's a 9 o'clock class that perhaps somebody would let you borrow it if they were so nice enough and inclined. But calculator, that's thing number 1. Thing number 2, GroupMe. There's no better day than Monday, Tuesday, and Wednesday to be sending questions and answers and feeding off of each other, and you see somebody else studying, so you think, oh, I should be studying, and that kind of thing. So please be studying, right? Get a calculator, test on Wednesday, study this week. I believe in you. We just got to, it's time to buckle down. I think that was it. Only 2 things, not 3. Please study. I really want you to do well. I want you to do well more than you want to do well, I promise. All right? That being said, let us get started. That was the third thing. There was a third thing. Third thing, on Tuesday, if you're just like, I need some more practice, from 12 to 2, I'll be in my office, just a little extra time, just chilling. So I'll be in my office just chilling from 12 to 2 for studies. If you have questions tonight and you're like, I really don't want to group me in, I want to come ask, Tuesday, extra office hours, that time. Cool? Sweet. Let's get started. Did anybody actually have a question that they actually needed help with and they know it? Yeah, thank you. Appreciate you being willing and ready. Number 2. Mm-hmm. Let's do the... I guess we should do D because it's the hardest. Right, the other ones are the same exact type of problem, just slightly easier. So, did anybody look at that neat little graphic I sent out? It was about this, the picture I sent, and I said, hey, this is pretty neat on the GroupMe. You see it? It was this. It was just this. So I actually really do like this, but I'm glad you asked it first, because later in the day, after we've done like 10 math problems, it gets kind of hard to just pay attention, and so this is nice that I got everybody, because I think I have a really fun way to explain what's going down here. Bless you. Okay. Instead of just telling you how to do the problem, I think it's important to know what we're doing. So pick a point, any point in the world. 1,2. Okay, I'm not actually going to write 1,2. I just needed a place to start. Let's say that's not 1. Let's say it's X. What's the Y value? What's the Y value for that point right there? Yeah, that's what I'm talking about. Now let's say we just go over this far. How far did I go over? What? That much exactly. And do we have a word that we use for that much? What? Yeah, but what's the word that we use for we went over that much? When you're missing the actual number, what do you use? A variable, right? Okay, but we already used x, unfortunately, so we got to think of another variable. Whoops. You know what variable they thought of for us? It's in the formula. But what's the only other variable in the formula? They just picked it randomly. I wish they would have picked A or B or C, but they picked H, so we're using it. So what is this? Not point. I'm not going to say point. What is this blue? So if this blue line is x far, right? How far is this blue line? Close. Super darn close. X plus H. Because look, and I'm going to erase it. Here's x far, right? Here's h far. Makes that x plus h far. Okay. But we didn't just go over. We also went up or down. How high did we go up? What point is that point? X plus h, comma. The blue point is, what is this box? It's close. It's f of. No, because that's the x value, right? And that's the y value right there. So the y value there is f of x plus h, right? And the y value, which I forgot to announce, but on that green dot was regular f of x. And now, don't we have this nice, neat formula for a line? What's the formula for that slope? Anybody remember it? Anybody remember the formula for that slope? Or that AROC? Yeah, isn't there a formula? Over. All right, now we got to label these green and blue points. Which one's which? So x1, y1, x2, y2. They're just 2 points, right? Technically speaking, we've got ourselves a green point and a blue point separated by h and whatever the difference is there. Which means on the top, we've got ourselves f of x plus h minus, right? That's y2. I'll do it on top so it's a little prettier. Minus y1, which is just f of x, over, all divided by, x plus h minus x, which once you get a little canceling happening, you end up with your pretty formula. So what are we actually finding? Here's what we're finding. That's me driving home in traffic. Sometimes I'm going fast. Sometimes I'm going slow, right? Sometimes I'm going backwards. I don't know. That's me driving home in traffic. If I started here and I ended up here, what was my average speed? My average speed was about that. Now, is that an accurate speed? Is that how fast I was actually going? Not very often. Just like right here and here and here. Only like 3 times in the whole trip did I go that fast. That was my average speed. It's not very accurate. You know why it's not very accurate? Because the h is really, really big. That's a long h. You know what happens if I erase that line and say, I want to take that dot. Not that dot. Not that dot. That dot. No. I want to take that dot. Take this red. Okay, well, I'm just going to, this is done. Draw it again. You know what? I'm going to take that dot. Thank you. I just want to take that. Oh, my God. Yeah, you don't even understand what I'm trying to do. Take that dot. Okay, got it, finally. And make h smaller. So which way do I have to go? to make h way, way smaller. Right? And what happens if I do that for a long enough time and I get really, really close to that other dot? You know what happened to the average rate of change? It became a lot more accurate. Right? If those two dots get really, really close to each other, and then I do the average rate of change, doesn't that kind of look like the line? But if they're really far away, it doesn't look anything like that. And that's the whole point of what we're doing here, is we're saying what happens when we take the slope and we really try to figure out the slope. And this is the whole premise of next semester. All of next semester, this is what you're doing. This is why it matters, and this is why we do it. Now, you need algebra to do it, but this is all of next semester is slope. Finding cool ways to find slope. Okay, sorry for such a long side tangent. If you would have looked at it this weekend on the group meeting, we wouldn't have had to do that. But I know you didn't, because nobody said, cool. How does this work out? A little different practically. Green. What's green? F of x plus h. So what do I do with that x plus h? Plug it in. So the green thing gives me 3 times. Any ideas? 3 times. Hey. Squared minus, now we switch over to using just x. No, we're doing the whole thing green, right? 4 x plus h plus 1. I always write a black minus sign because it's not part of this equation. Do a non-colored minus sign. And then we switch to a different color for the blue thing. What's the blue thing? Just a function. Just f of x, which they've already given you literally for all 4. Minus, big old parentheses, 3x squared minus 4x plus 1. All over what? Nice. All right, now if you're really good at FOIL and factoring, you don't have to, you can go 3 big old parentheses, x squared plus 2xh plus h squared, right? Because everybody knows how to FOIL. And then everybody knows how to distribute a negative 4. So you go minus 4x minus 4h. And then everybody knows how to distribute a negative sign. Right? Minus 3x squared minus 4x plus 1. Right? What? Y'all. I said everybody knows how to distribute a negative sign. Minus 3x squared plus 4x minus 1.
Okay.
And then, we got one more little distribute over here because I didn't do it in the same step. 3x squared plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared plus 4x minus 1. That's crazy. All over. But you know what happens in this problem that's really, really cool? Every time, stuff starts canceling. And if stuff doesn't cancel, start over. It's going to cancel. I promise it's going to cancel. Start over, try again. Go to a different problem, do that, come back and try again. Get some blank paper, come back and try again. If it does, stuff is going to cancel every time. So what cancels here? No, it doesn't. Just go slow and work through the problem and look for matchings. Right? Is that it? I really thought there was more than that. What? Oh, I missed something. This green one right here. Right there.
Okay.
Well, they cancel.
Yeah.
I don't know how I'm going too fast. Like I said, if you miss something, like I just did, you got to know most of it cancels. Now, I know you don't do them all the time, so you don't know exactly what's supposed to cancel. Basically, anything without an H cancels. Right? And then even some of those H's get to go. Whoop. So we got 6xh plus. That H goes away? One of those goes away? That H goes away? And you're left with? Very nice. Let me zoom out. Also, I'm going to post this if you even have time to study and want to study.
I mean, I know how to do it because I just walked through it with you.
That doesn't mean you know how to do it.
Huh? It does.
I watched LeBron play basketball. It doesn't mean I know how to dunk.
That's so different. Be so real.
No, it's not different. It's not
Yes,
different
it
at all.
is. No, yes, it is. To me.
Basketball, you need height.
No, you don't need
I get formula. You got. It's going to be worded just like the wording of the review. What? There's so many things that I could say. Like, no, I'm just thinking about like sports. Like, I watch football last night. I watched Patrick Mahomes go to the Super Bowl.
No, but
I can't go to the Super Bowl.
Oh my gosh, I've done it before. That's why I know how to do it.
Very true. I suppose if I buy a small enough basketball goal, I could dunk. If you make up an easy enough problem, you can solve it. All right, let's keep rolling. I took a lot of time on that. Let's move to another one. Another question someone had this weekend while studying.
Number 5.
Number 5. Don't mind if we do. Shoop. Shoop.
Yeah.
What?
Sometimes I do write a pen. I'm not
You should always write in pen. And then if you make a mistake, you know what you should do? Just draw one little line through it. Because then you're not getting rid of mistakes, but you're seeing what you've messed up before. As you study, you can see wrong trails. And then when you see a wrong trail that you've taken one time, hopefully it reminds you next time you accidentally go down that trail. Okay, well, here's take as much paper as you want. I really do. I think that math and pen is actually really smart. Or at least math without an eraser. You can still use pencil, but... What, a pen or a pencil? Yeah, I don't hate it. All right, this is like a funnel, right? It's like a funnel. Imagine you've got yourself some sort of sorter, a color sorter or whatever, right? I'm trying to think of something. Have you seen one of those cool coin sorters? Where you drop a coin in and it goes down the funnel, but it knows what kind of coin it is and sorts it for you? No?
Yeah. When you turn your
I don't know. No!
like when you do the pennies to cash thing.
And so when you empty a vending machine as a worker, you get all the same type of coin. You don't get one big bucket. How do you know that? Do you work on vending machines sometimes? Oh, that's fun, actually. Okay, sure. Or what's another thing that sorts things? It's a sorter. It takes the number and it sorts it, right? It sorts it just like the coin into the one of the 3 that matches. So what number did I just take? I totally forgot. Does 1 sort with less than negative ones? So watch this. Not even going to think about it for this problem. That's going to kind of come back to bite me later if I have to do all 4, but just for now. Does 1 sort with x equals 1? Yeah. All right, well then. Is 1 greater than negative 1?
Yes.
Sweet. So we plug it into here. ... How do you plug a 1 into negative 1? That's the answer. There's nowhere to plug it in. That's where we're going. It's just that. All right, now I kind of got to erase those things, and I got to sort a different color. Let's sort negative 1. Which one? Now, you could probably do this one pretty darn quick. Which one does negative 1 go through? The middle? Is negative 1 equal to negative 1? So then what do we do here? 4 times negative 1 minus 4. We don't just write negative 1 as our answer, though. It would be nice. We plug it in and we say that's actually negative 4 minus 4, which is negative 16. It's negative 8, right? No, I was trying to trick you and make someone say yes because they're not paying attention and they're on their phone.
I just watched a video on that.
I wasn't talking about you. Well, you just had his phone like this. What? It's fine. All right. We haven't. What color haven't we used yet? Red. We did use red. Green. 4. Where does 4 sort to? Oh, 4 goes to the bottom as well? It's greater than -1? Equals -1. All right. Where does black sort to? -2? To the top? Oh, that's a bad way to write that. Don't write it like that. That doesn't look good. I think we should write it like 2 times -2. Is that a prettier way to think about it? Equals -3. Is that okay? Cool. It's like a sorting machine. I don't know. I try to think of a different example. I can't. Something sure. Yeah. Well, y'all think of a problem to do. Coins is the best thing because I've seen like those commercials where it's a big bin and you drop them in and it goes into a bunch of columns. That's fine. That's even better because homework is fair game. The review is study material, not all of the things we've done in class.
It's the last question of 3.2.
That's not helpful to me right now.
Okay.
Yeah. This is the last question of 2.2.
It says a car rental company offers 2 plans.
Oh, that's fun. Okay. So we get. Hang on. So we got cars. And we're gonna have an A and a B probably, if I'm guessing.
Yeah.
All right. What are we saying?
Okay, so plan A, it's $30 per day and 13 cents per mile.
$30 a day. And what?
13 cents a mile.
13 cents
A mile.
per mile. And I'm guessing you're gonna give me plan B.
And then plan B is $50 a day with free unlimited mileage.
That's insane. You should never give anybody free mileage. That'd be an insane plan.
And then it's
That's cheaper than any plane ticket anywhere.
for what range of miles will plan B save you money?
Makes sense. Okay. I think this is lines. I think these are lines. And I think just to get started, I'm going to graph them because that's just all we've done with lines pretty much. And actually, to be fair, the blue line is pretty darn easy. Oh, wait, actually, before we even do that, we should say what's on each axis. Probs. What's probs on the x-axis? We've said this so many times.
30x.
No, y'all. X always has the same thing, pretty much.
It'll be time.
Time goes on there. Time as in measured in what?
Days.
Yeah, because that's the only time they gave us, right? So then what goes on the y-axis?
Money.
Dollar bill. Yep. Okay, so I think the blue line's way easier. If I rent the blue car for 1 day, how much does it cost?
50x.
Blue car. Yeah, 50. If I rent the blue car for 2 days, how much does it cost? 3 days? 4 days? It's a pretty consistent line, right? So after 1 day, how high did I go up? 50, right? That's bad. So that would be 50. That would be 1 day. There's a dot there. And we got ourselves. What? Days is on the bottom. 1 day, $50. Right? Now, what about the other guy? Oh, wait. You might be right. We need miles on the bottom, don't we? I might have just been tricked by our own time's always on the x-axis thing. Because miles is the thing that's changing. There's not even any time. Dang it, I was tricked by my own rule. That's so annoying. Well, it's still fun. Hey, wait. No, this is a great graph. This graph is true.
It's true.
It just doesn't help us at all. What about the other one? The other one's going to be $30. And how much does it cost? We don't know because it depends on the miles. But this graph is a true graph for the blue car. True or blue. Probably not super helpful. That's fun. All right, we'll hop back over. And you know what should have been on the x-axis probably? Not erasing it. Leaving it. Miles probably, yeah. Why did you say that earlier? Yeah, like, time's not helpful. I was just going with our rule. So we got miles and money still? Money makes sense. Well, that makes the blue line even easier. What does the blue line now become? If I run 1 mile, how much is the blue thing? 50. If I run 2 miles, how far is the blue thing? 50. If I run 3 miles, how far is the blue thing? It's always 50, right? At 50. That's the blue car. It don't matter how many miles you go. It's always 50. It's a $50 car. What are y'all talking about? Shh, hey, stop whispering. You asked the question.
I'm trying to show them where to find it.
Oh, okay. And what about the black car? How much does it cost just to get it? That's going to be a special number. It's going to be a y-intercept. And then you think it's going to get more expensive or less expensive? Duh. So it's going to get more expensive. And what point are we looking for? We're looking for that green point right there, right? We are looking for where the black car becomes equal to how much money? Shh, hey, what are we doing? You should ask a question there. Right? Pay attention. We want the black car to be equal to how much money?
Well, less than 50.
Sure. I'm just going to say equal to find that number, and then we can call it what it is. So, what's the formula for the black car's line? Y equals, is it 13 cents? 13x plus 30. So we're going 13x plus 30 equals, what number do we want it to be less than?
This is what range of miles will plan be saving money?
Oh crap, which one's B? B is the blue. A is the black. I'm just going to say an equal sign and then we can figure it out. Equals with a little question mark over it because we don't know which side we're looking for. We could say both. We could analyze it which way. Equals with a question mark over it and $50. Which means you get 0.13x equals 20. Which means you get x equals. Means this was on the calculator portion. Calculator people, help me out. If you get something like that, calculator portion, so that kind of means 153? 153 what? Miles or dollars? You think? It's X, right? What was our X right here? Miles. 153 miles.
Do it round up.
No. It's exactly 153?
No.
Oh, then don't say 153. Say 153.84.
And then it would be 8.5 because it's 6.
Okay, that's fine. Okay, so at 153 miles, something happens. Which one becomes more expensive at 153? Before that, blue is more expensive, right? After that, blue is cheaper. That's kind of interesting. So now you got to go and see what the question actually was asking you. I don't remember. On which one, though?
For what range of miles will plan B save you money?
So, any miles over 153.85. Also known as 153.85, comma, infinity? I think so. I haven't looked at that exact problem, but that feels to me like
It lets you put it in interval. Like it gives you
cool. I don't know the number for yours exactly, but was it right?
Yeah.
Amazing. Did you do inclusive brackets or non-inclusive brackets?
Oh, I didn't do that. I just put 1.85.
Oh,
Oh, sorry.
Oh, because it just says it must be greater than blank.
They don't.
oh, it gives you. It must be greater than.
Yeah.
It must be
Greater than.
greater, and it probably says the word too, right? Not the sign. It must be greater than.
This is the word.
Yeah.
And
To
the
this.
only options they give you is like that number or like the full number.
Sure. All right. Thank you. That's a good problem. That is a great problem to have. The trick there, the trick was the hard part was this step right here, where we said, hey, wait, we've got one equation, which is a linear function. We got another equation, which is a constant linear function. Where do they meet? That was the whole trick, and the setting it equal to is where they meet. All right. Anybody else?
So I assume it would be on this because it was in the bracket of the thing, you know?
Hmm?
Like the homework that was due just recently. 2.2 wasn't in there.
So it is.
Oh, I didn't give you 2.2 homework?
No.
How nice of me.
I know, so I'm saying like.
Well, I should have, but
Be on the test, right?
did you do the 2.2 homework?
Yeah.
You just went ahead and did it early?
Yeah.
That's pretty smart.
We did the homework for it.
You mean the notes for it?
I mean, we did the
In
work
here.
for it.
Yeah, I must have forgot, but I'm not gonna.
Okay, Slay.
No, I didn't say put on the test. I said I'm not gonna like give you homework right now and be like surprise homework. If we did in class, it's on the table. Sorry about the homework situation. Also, you're welcome for giving you less homework.
Are you sorry?
Is 2.2 mentioned?
Yeah, I think so. We'll just have to do it maybe right after the test, and I'll. You can go do it now though. It's open. Okay. What else are we doing here?
I have a question.
Anybody in the back? Anybody in the back? Anybody in the back? You feel like you're so good at math that you're gonna be great? What you think?
But I don't need you to solve out the full thing.
Sure.
Okay. For number 6, it's like for D,
Okay.
you want us to like have our answer as x cannot equal blank.
Your answer is not x cannot equal blank. Your answer is gonna be long thing over shorter thing,
Okay, and so we leave it like that.
and then maybe right to the side you say, hey, wait, but I also know the domain. The domain is negative infinity to that number you just said.
Okay.
That number you just said to infinity.
Okay.
That's what that answer is. What you're saying?
Yeah.
Now, if it doesn't ask you for domain, you're not going to be counted off if you don't say that,
Okay.
because this one doesn't, right? But remember, during the year when we were learning it, it did say also tell me the domain.
Right.
So worth thinking about. Maybe you get extra credit if you add it and it doesn't ask for it, because that's pretty smart of you. But
We heard about
this one, I'm pretty sure though, we did this one last. You can go and watch the video. I don't think anything factors or simplifies on the division one.
No.
For this one, I don't think anything like the top doesn't factor and the bottom doesn't cancel. It's just literally just rewriting it.
I know. I was just
Like,
asking them to find something.
yeah, the answer is just that right there, right? Yeah,
How many points do you take off? Just take
so all of them. No, I don't know what. For what?
like if like it was like simplifiable and we didn't simplify.
Depends on if the problem says simplify or not. That is the answer to that question. Ones that are very clearly simplifiable. So, for instance, that's not possible. Oh no. Oh, there we go. Is that good? No. That's good. That would be probably minus a point if you left it there, right? Because I know it stinks, and I know some people are like, I gotta leave it there because I can't do it. But you got to be able to factor. Note the domain restriction.
So we
and then cancel.
That would be our final answer.
Yeah, with probably this side note of x better not be equal to -1, or if you were to solve it because maybe it actually set it equal to something, you need to at least have this note somewhere so you know what if the solve happens to be -1 at the end of the day. You got to kill it, right? Because you did something right there in the middle that made your removable hole or a removable discontinuity, which looks like this on a graph. So, but that's the answer. That is my shortest answer to your question is that is going to be at least -1 or 2 points off. Not 10, not the full question, but like the purpose of this was to see simplification happening. Whereas the really long, difficult one where maybe you could have quadratic formulaed this and got it down to -10 plus or minus the square root of 37 over 3, right? And so you could have done like x plus that times x minus that. Like that's not a thing. Where it's true, it's a true math statement, but it's not the purpose of the problem is to get a harder answer.
Did y'all work number 9 on that first one?
I don't know, man, but my computer is getting blurry, huh? Is it this? No, that's still going. No, sorry about this. Let's close everything else. Uh-oh. I better go home.
For the lab hour, we're doing the same thing.
Yeah, we're just going to keep going through problems. We'll take a little break in a second, though, if I can figure this out. That's fine. Oh, no. Y'all. Computer froze. Too much math. Fucked. We might have just lost that hour. Oh well. If we did, say let me. Maybe we didn't, but maybe we did. Number 9? Yeah, we can do it. We can do this one pretty darn quick and then we'll take a break. First step. First one. What are you plugging in? Where are you plugging it in? How many X's do you see? I see 3.
Oh.
Just for fun. F of 0 equals root 0 over 0 plus 1. You cool with that? Watch this. It's pretty fun. What's the square root of 0? What's 0 plus 1? What's 0 over 1? Undefined? I got 2 little over here. What do y'all think if y'all don't think it's undefined? Equals 0? All right, fight. Fight each other. Is it undefined or is it 0? Someone's got to give me a justification and not just an answer because your third grade teacher told you that. That's a good decent answer. A counter example is a decent answer. Are you on board with them now? No?
I put it in the calculator. Do it. Jump over.
Oh, there's an even better proof. Tangible proof. You put this in the calculator?
Yes.
And what did it say?
0.0000. Oh wait, no, I didn't.
That's not true.
I lied. I'm thinking.
It said error? Okay, so the calculator backs up undefined and error being that, right?
Yep. It says.
What about 0 over 1 if you put that in the calculator?
I mean, that's the one that says 0.1. I mean 0.000. It says 0. It's just 0.
So it's just 0?
Mine
All right.
says 0.000.
I like it. 0.
I don't
Good.
know what's wrong with it?
Good exploration there. What about F of 2? We're going root 2. Ooh, root 2. You know what root 2 is? You know what root 2 is? Y'all know what root 2 is? No, you don't know what root 2 is. Nobody knows what root 2 is. It never ends. Leave it alone. No, you know what root 2 kind of is. You know a approximation of root 2 if I round it to the tenths, hundredths, thousandths, 10,000ths. But you don't know what root 2 is. Neither do I. Leave it alone. You can't tell me. Better not stop ever, because I'm going to tell you that's not root 2. That's an approximation of root 2 to the hundredth decimal. Now, this is the one that you were actually asking about. A plus 2. How do we do this? F of A plus 2. What goes under the root? What goes into the bottom X? And does anything combine here? Can you do anything with this? You can't do anything with that. There's nothing to be done. There's nothing to be done. Don't try. Unless there's a magical A plus 3 that you can pull out of here to cancel. That's it. You're done, right?
Yeah, I think what I got confused on because it didn't say A, B, C, and D.
Oh.
You know?
I didn't know that. Did it not say that?
It's
Oh, yeah, that's fair. That's fair. It's a little different wording.
It is. And then B says determine the domain of them. That's
Sure.
where it goes.
All right, one more question before we take a break. Number 3. Nice. This is a good one. We didn't do this last class. I think everyone so far we've done last class. No, because I want some people. Most people are not going to watch the videos, so I'm not saying you should. If you really got the good grasp on this, you got it. Do your best.
You need the numbers?
But smash that like button when you do watch it.
Okay.
No, I'm just kidding.
Okay.
If you're watching this right now, just go ahead and smash that like button. You gotta scroll down, whatever. Comment and subscribe. Don't do any of that, please. Actually, don't do. What? See you in class. Points up for him. Flag him. This guy This guy messed up in that minute 2.3. He used the wrong graph.
Let's do a fun one. Let's do B.
B is fun because it has the fraction.
Yeah.
Okay.
Y minus. Oh.
Wait, we need the formula.
Y minus y1 equals m parentheses x minus x1. Yay.
Which means we're going, oh, this is so easy.
Yeah. And
Right?
Y.
I mean, I didn't write the questions, but this is great. This is not a hard problem. Y minus 1.
Equals 1 over 2 x minus 7. And then we're going to.
Not and then. Look at what the question asks for.
Oh. I lied.
Right? That's why I said it. Oh, wait, this is way easier than I thought.
So I have a question. If it's on the test and we keep going, you gonna count it wrong?
I mean, I need you to box that. No, usually I'll go backwards and be like, oh, check mark, and then be fine. But I would box both. Actually, here's the best answer. You want the best? No. You want the best answer for how to answer any question? You get to something you think is the answer, and you write right here. You go slope, intercept. No, that's not true. Yep, point, slope. And then you keep going. And you get it to be like y equals 1/2 x minus 7 over 2 plus 1, right? Which is actually y equals 1/2. I don't like writing like that. I like writing it next to each other, like 1 over 2x, like that. Minus 5 over 2. Box that a different color. Go slope, intercept. That's the best way to answer any question. No, it's not extra credit. It just shows it's good practice. When you grow up, your boss ain't giving you like a answer and saying, "Give me the answer." You just say, "Hey, go solve this problem for me," and he doesn't tell you, and you just do a problem. You go and solve something, and you come up with 3 or different 4 solutions, and he pays you for the best one. Okay. What time is it? 51. We're gonna start back up with 7D. I couldn't tell you. Switch y and x. Switch y and x. You got x equals 2y plus 1. X minus 1 over 2. Yeah. Is that what you were wondering? I don't do that. So this is the tough one. I was helping somebody with calculus this past week, and this concept came back up. So for this problem, I was like, oh, we just did inverses in precalculus, and this concept came back up for him. It was with the hard problem with like a y and an x and a dx dy plus x to the y, like this kind of thing. But this was actually on the other side. I remember it was like this plus 2x squared plus y prime. And his goal was to get this by itself. But that's hard to get by itself when you have 2 of them, right? And these don't combine nice and neat. These don't combine nice and neat. But he wants 1 y prime or y1. So this is the concept that we're about to hit on this. Yes.
How do you feel about transferring to calculus next year?
Yep. You're going to be great. You're going to do a great job.
Which one? No, like, yeah.
I can't wait to see you all thrive. I talked to them, the students that are over there now, and they're doing great. They love it. Just talked to 2 of them.
Wait, why did those cancel? Why are they coming?
All right, here's what's happening. No, I was just on at lunch, and I was visiting with them over by Chick-fil-A. Here's. So what's the first step? What I just said we're going to get to later. What's the first step? Y equals 2 x plus 1 over x minus 1, right? Second step. I'm not going to draw an equal sign because it's really not equals, right? We're changing something. You can't, don't keep going with equals. Like it's a flip, right? It's actually an invert, right? So I don't know what to call it, but I'm doing an arrow, so I know that I'm not equaling this whole string. I'm just kind of keep going in my thoughts. So I'm going to call it x equals what? 2y plus 1 over, whoops, I've put x and it's not. It's y minus 1. And now you can draw your down line and try to figure it out, right? And see where this is pretty similar to the problem I just said was happening. He's got 2 y's and he wanted 1. Now, in his case, it was y prime, or the derivative of y, but You got 2 y's and you want 1 y.
I have a question. Would you do keep, change, flip or no?
I don't think it helps. Keep, change, flip is for when you have a fraction over a fraction. And I don't see that happening here. I only see one fraction.
Just multiply. Oh, yeah.
I see a binomial over a binomial, but not a fraction over a fraction. All right, what were you saying? Sorry to me.
Multiply on both sides.
Multiply by what?
1 and 1.
So you're just trying to get rid of the fraction.
Yes.
Which honestly is what keep, change, flip does. It gets rid of 2 of your fractions for you. So, but it's just a different. This doesn't have keep, change, flip because it doesn't have fraction over fraction. So you tell me that gets rid of that. But what you do to one side?
So it would be. Oh, okay. X, Y minus
Well, now what? That wasn't helpful.
X, Y. Oh,
Oh, you're doing the distributive property already?
X, Y minus X equals 2Y.
All right, somebody else. That's you too. Thank you, then. Sure. So minus 2y is what you're saying? So xy minus x minus 2y equals 1. Any next thoughts? I'm running out of room, but no, man. Like that? All right, I got to restart. This line, I'm running out of room. All right, somebody else, though. Luke, what are you doing back there? People in the other class are just taking over. They're going to do better than you on the test because they're doing good at this. I'm going to need you to step it up. The back row over there. I feel like they're doing a poor representation of how I taught last year. And you 3 are great. Not you. I'm not talking about you. I'm saying these 3, 4, 5, doing a great job of showing like, hey, we can participate in class. And y'all back there are like, we're too cool for school. What? What do you mean? What? What about it? You answered a lot of questions? I didn't remember that. Did you know how to do this? No, but this secret step of factoring out this x right here. Yeah. I'm just asking. You're welcome. It's probably the headphone is all. The headphone's throwing you off. What do we got going on? X, Y. It's not okay. I promise you I want you to do better on your test than you want to do. I promise that. Now what? This is the sneaky step. This is actually the whole reason they all did this right away and they knew what to do because you've probably just done one like it before, right? It's not an obvious thing. Like, you don't have to do this. It's just a random manipulation of things, but it all serves the same purpose as to what we're about to do. We got only terms with a y on the left side so that we could do what? No, we don't need, well, how did we get y by itself? What's that called? You are right. We are moving it to the outside like that, right? What's it called to do that? Factor out a y. And last but not least, like that. So y equals 1 plus x over x minus 2. But actually, that what? What did you say? I don't think so. I think no. I think that this step right here is not obvious for everybody. Honestly, maybe not that step. I think it's right here. I think this step right here. I think there's a lot of. I've taught this class a lot of times, dude. I've taught this class a lot of times. I've graded a lot of test ones. I think that step is not obvious, and there's a lot of trying to cancel out this y somehow. Like a lot of it. Right? Well, this is still not right. This is still not right. F. It matters. Just like you matter. I see. You do matter. You're welcome. There you go. I'll zoom out for you. Problem number 7, Max. Yeah. That's true. I just want you to do well. That's all. I want you to do well.
He went as good as that.
I agree.
So he said.
All right, what else we got? If that were true, you could just make the test really easy.
Let's do.
It's bold over there. Lucky you, I just had Chick-fil-A, so I don't need any. But no, that's too spicy. Yeah, very.
What did you say?
Too spicy.
No, they're not.
I didn't say they weren't too spicy for you. They're just too spicy for me.
Ah.
All right, what are we doing? Number 10? Hey, no laughing. Which part of 10? 10's way too long. I don't.
Way too long. All right, on the test, all right. This way
This
too long.
this test is way too long.
I quit this test.
Wait, how many questions are we?
How many questions are on the review?
22 questions. No, it's not. It's more than that. It's 22. No, it's like multiple in one. You know, it's like A, B. That's like different stuff.
I don't know how many. I haven't made it yet.
No, not all of them.
Formula.
You make it the day up?
Back row. Someone on the back row. I need the formula. A. Subtract 2, cube the result. Give me a formula. Who? X minus 2 cubed? All right, that's probably 8 out of 10 points. What are you missing? That's probably 9 out of. Yeah. It says if you did Y and it didn't have this F right here, then yeah, but it's got that F right. So don't do that, please. And, though if you did F of Y and had a Y in the middle, it'd be fine because nowhere here says F. You have to have X, right? Okay. Someone wearing orange. That was actually pretty mean. Sorry. I was thinking there'd be more than one person. It's my fault. Orange or blue. Somebody wearing orange or blue. Hit me up with F of -1. F of -1 is? Really?
-1 minus 2 is -3 cubed.
Oh,
-3 cubed.
27. Yeah, you're right.
Cool. Who said that, Luke? You're not wearing blue.
I was trying to do it.
Got it. Cool. Somebody wearing black. Give me the 0. I got a -8 from. We cool with that?
Yes.
Somebody wearing gray. Somebody with gray on. Give me that 1.
Can I have an answer for blue if I technically have a blue crown?
I don't care. -1? Because 1 minus 2 is -1. Cube it. Cool. What about 2? Anybody? Nice. What about 3 is the last one? No, 4 is the last one. 3.
1.
Somebody born in December. 4. Honestly, you could probably look at the table and tell me.
Can I tell you?
Sure. Were you born in December?
No.
Then no. Who was born in December? Yeah, that's not a good one because you can just lie. Yeah. Everybody gets your IDs up. We're going 8, right? Cool.
Your birthday.
You should totally finish the graphic.
What does the graph look like?
The table.
What does the graph of the parent function look like? A snake? And what do we do to it?
Move over to the right 2.
Like that? Finish the table?
Or just erase.
No, it only asked for 4.
Just erase the bottom.
It only asked for 4.
We're gonna erase the bottom.
Yeah, then erase the bottom.
Or just. He hates us. Oh, I thought you were gonna leave that.
Thank you.
You're welcome.
Joking.
Check. How do we know? Oh, that's the hard one. How do we know it has an inverse? That's the easiest way to know right there. I know what the toolkit function or the parent function looks like, and I know that this is just a horizontal shift which does not affect the shape at all. Therefore, I know that if I run a horizontal line up it, that means it is 1-to-1, which because of the HLT, which means it is invertible is the cool word. Whoops. Inveritable is also a word, but not the word I was trying to spell. Invertible. 1-to-1, horizontal line test, invertible. Now, if you wanted to go find the inverse and then set f of g of x, actually, let's do it even prettier than that. F of f invert of x equals to x equals to f invert of f of x. Power to you. Do it. That x is what you're looking for. Do you think you could find the inverse of that function if you had to? Oh, that's question E anyway, so you do have to. What's the inverse? Something like you gotta. I'll do this one. Someone wearing black, do it. Okay, I will. Cube root x and add 2. Did anybody invert it yet? You can check it on your own, but looks like it. So we got ourselves a table. We got ourselves a graph. We got ourselves a 1-to-1 proof or a second 1-to-1 proof if you want to be really thorough. And then we got ourselves the actual f prime or f inverse, which is that. So that is A is up here in blue, then B, C, a different way to do C. Wait, this is E? Oh, this was C. C's the graph. Those both D. All right, y'all. Let's dig in. We got a little bit of time left. This is the last little bit of studying we got. We need to make the most of it. What question are we working through?
Oh, wait. Can you go back?
No. Honestly, the first one we started with, that difference quotient one, with the if it's a quadratic difference quotient, that's the toughest we're getting. Right? And then every once in a while, people mess up, like, fractions. Oh, we did do a kind of tough one because fractions stink. First hour. I'm looking for it. I'll recognize the fraction. There she goes. Right here, whatever this one is. What's this one? What is there one that looks like this? I don't see the number.
Which one? Yeah.
Oh, it's right here. Is it with 2 plugged in? What makes it look like that? 2 plugged in?
No, it was 2.
2? 10?
I don't know.
What is this problem? No, we did. No, I'm saying, what is this problem right here?
Maybe it was a homework.
From 2 to 10 of...
Oh, that was the... Was that the car one?
No, I'm saying it was from 2 to 10, find the average rate of change of this function.
Is it number 12?
I don't know.
Are you sure we did that here? No. I think we did that last time.
Oh.
I thought he was talking about from first hour.
Interesting. No, I know. I'm just saying, is that on here anywhere? Where's the average rate of change section? Right here?
Number 12 and...
You said number 9? Oh, I didn't even see those parts of 9. Yeah, 9's got some good parts, B and C wise. Did we already do 9A in this class?
Yeah.
9's got some good parts with B and C there. That stinks that it's on a different page. And by good, I mean, like, they're annoying because of the fractions, but they're good practice for you to see, like, oh, yeah, fractions do matter. Okay. So we got ourselves a function, which is f of x equals root x over x plus 1. Can you tell me the domain of that? That's tough. There's some challenge there. Any thoughts on that? This is number 9, B and C. It's on the back side. It's a 2 split page. Next time I'll have to be more careful about not doing that. That way it's not.
You try to avoid that.
Oh, yeah. So that comes from the bottom, right? X better not be -1. Love that call. There's one more call to make. There's a better way to say can't be negative. I mean, you could try to write every single negative number ever and go, X also can't be negative 0.001. You know what I'm saying? You could write every negative number in the world, but there's a really nice, neat way to say X better be positive, and it is X is bigger than or equal to 0. Right? And now how do we put those on a number line? 0 matters. -1 matters. X is bigger than or equal to 0. So does that -1 actually matter at all? No. Good to make a note of, but it didn't end up mattering. And that means our interval is from 0 to the infinite. What? Is that okay? That's okay?
Yeah.
Okay. Really? That doesn't sound like convincing.
Okay.
That's good? Remember the domain? How did he get those so quickly? He thought to himself, there's 2 bad things. There's a number over 0, which was the case here. So it better not be 0 is that blue case. And then the other domain restriction would be the square root negative is bad, right? Which means he took the inside and said that inside better be bigger than or equal to 0. The whole inside. Those are the 2 conditions for domain. And the green one turned up right there. That's the inside. And the blue one turned up right there. That's the denominator. Kind of fun. Now this average rate of change one's where they got all up in it. Well, they're just being complainy. And it's like, stop complaining. Formula for the average rate of change. That's a better one, right? Do we know y2? Well, we can, though, right? We're going to do some plug and chugging? Fine, let's do it. What's f of 2? Root 2 over 3? Right? What's f of 10? Root 10 over 11?
We put the 5 inside and 2 outside, or no?
Well, I don't know what you're talking about.
For the root?
For root 10? Root 10. Okay, so this is the question you're asking. Hey, can we reduce root 10? Question mark?
Yes, you have to.
Try it. What does it break down into?
5 and 2.
Are any of those perfect roots? No. You got to have 2 matching numbers. Like a 4 would have been dope because it could have broken into a 2 and a 2. A 2 and a 2, which match, and you kill them and bring them to the outside. But if it's no, if you get it down to it and they're all exclusive primes or different primes, it's kind of as simple as it gets. It's not happening, Captain. So those are our 2 numbers right there. So we end up with root 10 over 11 minus root 2 over 3 all over 10 minus 2. Right?
Yeah.
Y2, Y1, X2, X1. And now you can take it away with what you wanted to do. Now you got a fraction over a fraction. That's what they were saying too. Can we simplify that? You can't simplify that?
Do you get
Got to get a common denominator. Can't do nothing without a common denominator. So I'm going to multiply by 11 over 11. And 3 over 3.
Oh.
And we're going to get something like
I was thinking out loud.
3 root 10 minus 2 times, I'm going to do 11. 11 root 2 over 33. Bigger over 8. Woof. Keep change flip. Keep the top fraction. Change the multiplication. Flip 8, and 8 turns into 1 over 8. Excuse me. So you end up with 33 times 8, which is 264. Did you calculate it? Oh, I thought you were about to. Not bad. I'll do, Lottie. I'll do. They were complaining about that one, though. They were saying, I don't like doing the freaking square roots and the, what's it called? Reducing square roots. Least common denominator. Keep change flip. All these things they didn't like doing in one problem. Last class, 9 o'clock, 9 to 11.
Is there any rule saying that if it's not a function, it can't also do
Yeah, 100%. Because the definition for one-to-one, that's a great question, especially for like matching and is it one-to-one or is it a function or not? That's a great question. Function or not? This is a good question. I'm glad you asked that. Function or no? One-to-one or not? Cool. Good job. Function or not? One-to-one or not? But wait. But
He knows that.
horizontal line test. Why? Because the little title of that section was 1, 2, 1 functions, right? Right. So doesn't even matter. That's like saying like I don't actually know. Never mind. All right. What are we doing next? I don't know. The homeworks are usually harder than this review, actually, honestly. Yeah. What's it looking like? Nice. I mean, we've done something. Well, also, I think 11 was, almost a pretty darn similar graph to the homework notes. Maybe a little bit different, but. All right, this is going to be fun. I like this one because you get to highlight. Oh, yeah. Let's find a minimum. Let's find a max. Maxes are greens. That's for fun. Where is a maximum value? At 4? 1, 2, 3, 4. I don't think that's maximum. Yeah, boop. And what is the maximum? Oh, that's where I see.
Yeah, what did you ask?
Where is it? It's tough. I know it's tough. So the max relative or local is the same word. Relative or local maxes. Y equals 4 at x equals 3, or also 3 comma 4. There's another one?
Maximum? No.
Yeah,
Where?
right there.
Oh,
Y equals -1 at x equals -4. Even though it's lower, it's
I know.
because if you zoom in big enough, it looks like a max. I don't know. What does my open math have you do on the homework modules? Do you remember? Yeah, sometimes it has the blanks, right? I see it. The only reason I'm teaching it with both is because I see it too often with both. Because the word maximum really is asking what? But the word max really is asking about the y value. When I say what's the maximum height, that's the y value. When you throw a ball up in the air and I say what's the max, you're talking height. That doesn't tell me what time that occurs at. That doesn't tell me where it occurs at. That's why sentences matter so much in math, because it's like, no, the max gallons of oil that we can get out of this pipe yard is this. That's not helpful. That just tells me the max money I'm making. You really want to know how open is each valve, what's the mixture, how much more of one product do I need to pour than the other. So the words matter a lot, especially when you get to practical applications of math like this. Words matter a lot.
Absolute is the top one. Is there
Well, hang on. Oh, fine, yeah. The absolute is y equals 4 at x equals 3.
So the local can be an absolute, but an absolute can be
Well, what? What's the difference? The absolute is actually the peak. Zoop. That's the tallest that function ever gets. That's the absolute. This one is just a local. It doesn't matter. That is absolutely the biggest that ever gets. Likewise, that is absolutely the smallest it ever gets. Right? No, it's not on the line. See how it's like above the line? That's just bad printing, but whatever. So the absolute min, well, we haven't done mins yet. What are the local mins? -4 at x equals -1. And that's also the absolute, because there's no other locals. And the endpoints don't combat it. Endpoints aren't local maxes or local mins, because you can't zoom in and see a turnaround. Increasing, decreasing. Not the worst thing in the world, but we should go ahead and do it since we're here. Any thoughts on where this increases? I'll make it green. That interval and that interval, and then I'll make it red. Like that. And then it's up to you to find those intervals. I know they're not perfect numbers. They'll be perfect on the test. Don't worry. Those aren't perfect numbers at all, though, are they? It's like -5.5. Isn't it? I'm starting at the dot.
It's not on line.
I thought it was 4.
1, 2, 3, 4, 5.5.
You're talking about that.
Oh, you're talking what? Intervals or x's? Okay, that's a good thought.
Wait.
I thought we talked about that.
Because it has the solid, it's not going to be considered
What?
negative infinity to negative.
Oh, because the dot's there. No, it doesn't go for infinity. Correct. So it stops around 1, 2, 3, 4-ish. And then the other one is like -1 to 3. What?
I see. It's not all the way. I thought it was 6.
No, it's almost the same. It'll be perfect on the test. These are just kind of thrown together. And then decreasing is going to be -4 to -1.
Is it not -4
And
for the green?
for the what?
For the green?
The end of it? 1, 2, 3, 4, 5. Oh my gosh, you're right. 1, 2, 3, 4. Oh wait, no, that's right.
No, the first one, -5.5, comma 4. It's not 4, it's negative, right?
Yeah, that's what I said.
Okay. Yes.
No, you're right. Yeah, good call. Good catch. And then 3 to, I don't know, 1, 2, 3, 4, 5, 5.5 again, maybe? Even if it's not right. That's decreasing. That's increasing. That's the answer to question 2.
Oh, and then they went, without the 1.7 and 1.8.
What? Not for intervals of increasing or decreasing now. They're not united. They're not a set. They are 2 different intervals, right? Domains have unions, but that's because domains are what can x be. He didn't ask you what can x be. He just said like, hey, give me 2 spots where it's increasing.
Okay.
Got a couple more good ones in us. No, you have a test?
Remember to take attendance.
Oh, that's a good idea.
Let's try 13.
What's going on with 13? Well, hang on. 13 looks like a good problem.
I mean, like after this.
13 looks like a great problem, actually.
Yeah.
It's got a little bit of everything. You said compression and stretch? Did you say, do you want to do a compression and stretch thing? Nah. Just for the sake of saving our time. And we can do it in office hours. We can do it for your benefit. But for the sake of Wednesday,
Oh, okay.
okay, come to office hours and we'll do it because I want you to learn and you need to learn good. But for the sake of Wednesday, if you're really thinking, let's make most of our time, let's do 13. Linear. Holler out. Which one is it? Oh, crap.
1 minus 5x.
Which one's linear? Why? How'd you know? Because the square makes it not linear. The square makes it what? Parabolic. Parabolic? Parabolic? Parabolic. Why is the other one not linear? X squared means parabola. Cool. Sketch the graph. Are you kidding me? Zoop, zoop. What's a normal parabola look like? And then what are we doing to it actually? What is that shift that we applied? Like that? Cool. What about the linear function? This is actually good practice from class. Y-intercept of? Nope. It's not. No. We've had this discussion at length.
Oh,
It's
0,
0, yeah, that.
That's the y-intercept. It matters. One's a number. Let it happen again. So, what? And then what do we do from there if you want to make this as easy on you as possible? You take the slope, which is, but sometimes you write it -5/1. And that means you go down 5 and to the right 1. So we get to go 1, 2, 3, 4, 5. 1. Put another dot. And then stop there and use your ID. Don't make 3 and give yourself more of a chance to mess up. Do the 2, use your ID, draw the line. Well, that clearly points out which one's linear and which one's not, if you couldn't get it from the square and all. Now, what is the rate of change of linear? Ooh, we got to know what rate of change means. Slope. So do we already know that? So m equals -5? What? I'm just kidding. What is? No, we can wait. I go fast. I apologize.
This is why your students are scared to talk to you.
No, actually, I think that's quite the opposite. Believe it or not.
He's not approachable.
I think it's quite the opposite. If you were actually mean, I think people would be even more scared. Right?
I figured it out.
Yeah.
Have you not had a professor that's actually mean? You're like, okay, this isn't even worth it. Right. So,
I am terrified.
actually, I entirely disagree with you. Because I've had students come in and be like, that professor's way too scary. And then I'm like, just go talk to them. They don't care. They're just trying to get you to get a good grade, too. They just have a different way of doing it. Their way of trying to pull out goodness is mean. Oh, we got to do the composite. That sucks, actually. All right, f of g of x. We haven't done this yet today, have we? In this class? Have we done this today? No. Okay. Holler out. What was f of x? I don't want to zoom back up. Okay. I think this is how I'm going to do it from now on. I don't know. As we move on in class, we'll see. But you said it's x plus 5 squared. Because that's on the outside, right? F of. And then what's g of x?
1 minus x. I mean 1 minus 5x. So great.
Like that?
Yeah.
Y'all kind of see what I'm talking about there with the inside-outside functions? That's kind of how me and my last class finally sorted it all out. So now we're talking 1 minus 5x plus 5 squared, which is negative 5x plus 6 squared. And y'all are masters of FOIL, right? Everybody's just like, boom, FOIL. My middle name's aluminum. I'm just gonna negative. Nope, it's not negative. I messed up the first pin. 25x squared minus 60x plus 36. Right?
Sounds okay.
Is that okay?
Possibly.
I think that's right. And then we're done. That's f of g of x.
Huh? What'd you say?
That's f of g of x.
Oh yeah. And
So then what do we do with f of g of 2? Just plug it into there, right? This is crazy. So 25 times 4. Well, hang on. 2 squared minus 60 times 2 plus 36. Calculator, people, help me out.
Which one you need?
Oh, this is the whole thing. Actually, I don't. That's a hundy. That's a hundy, right? Minus 120, so that's negative 20 plus 30, 16.
Wait, pause. Why didn't you square it?
We did.
Oh, LOL. I did it wrong. Ignore me.
16 okay? Someone who's tracking and actually doing the work?
Okay.
Nobody did it. Nobody did the whole review already beforehand?
No.
One person? Isaac? You did it?
Oh, don't know.
Guys, had a whole weekend. What were you doing while I wasn't grading your labs?
Taking another taking notes. Biology.
Hang on. I want to show something cool. I want to do something cool. Don't start getting crazy. What time is it? We still got time. Barely. What's g of 2? What's
Is it 100x squared?
1 minus 5 times 2?
Oh.
So 1 minus 10, negative 9. What's f of negative 9? Negative 9 plus 5 squared. Negative 9 plus 5 squared is negative 4 squared. Is that the same answer?
Oh, so that looks like the easier way.
Well, we'd already done, but we plugged 2 into G, and then we took that answer and plugged it into F, right? We went from the inside, outside, working our way out. Different way to do the same exact type of problem. I prefer that. I do it step by step. Or if you're working on a table, remember that one? We did the same problem with a table, where you would go and do it once, and then you take that number and find it up here and do it again.
Oh, yeah.
Yeah. Same process of table. X plugging it in a couple times. It's going inside of the next step of the composite. Okay.